We've talked about carbs, let's talk about lipids. Lipids are fats. That's the way you store energy. Remember, carbs are for energy right now. It's for energy you need right at this moment. If you have extra energy, if you eat more food that has more energy that you can use right now, then your body packs it away for later. That's a survival strategy of metabolism. Contains over twice the energy per gram as carbs, lipids do. Remember, 9 kilocalories per gram, whereas carbs are only 4 kilocalories per gram. Compact storage. So it's very, again, the fact that they have over twice as much means that for each little chunk, you've got a very high efficiency storage mechanism. Glucose and protein sparing. So what happens here is that the brain, as I said before, really wants glucose. And heart muscle and skeletal muscle, though, are happy with lipids. So for those muscles to use lipids for energy, that saves glucose for the brain, glucose sparing. Protein sparing, the last thing you ever want to do to get energy is to have to break proteins down. Get this clear in your heads, kids. Proteins are not for energy. Proteins are way too valuable to use for energy. The only time you ever use proteins for energy is if you're literally starving to death, okay? That saves glucose for the brain, as I said. Prevents the body from having to use protein for fuel. There you go, all right? Remember, the fat-soluble vitamins A, D, E, and K are absorbed with dietary fat. In the lower right there, lose up to 15 pounds in 15 days. Wow, a new formula with 3 times the fat burning power. Ooh, look, it's got a pie chart. It must be scientific. Suppress appetite, boost metabolism, block fat. Try it for free. I lost 10 pounds in under 2 weeks, says Leslie C. of New Mexico. Don't ever waste your time on crap like this. It's just complete crap. The way you control your weight is with diet and exercise. There's no magic formula. And on the left, you see a person with anorexia. When you don't eat, like I said before, if you run out of all your carbs and you run out of all your fat, your body has no choice but to start dissolving muscle for energy. It's a very bad situation. So what do lipids do? Oh my God, what don't lipids do? They do so many things in your body. Yes, they're for energy storage, but they do other things as well. So, structural, remember the phospholipid bilayer going around every cell in your body is made of lipids, phospholipids, phosphate head, fatty acid tails. You can see there in the bottom left diagram. Cholesterol, remember, stabilizes the phospholipid bilayer. Also, lipids used to make myelin for myelin sheaths. Chemical precursors, cholesterol is the precursor of steroid hormones as well as bile salts and vitamin D. Vitamin D actually is a steroid hormone. Fatty acids, precursors of prostaglandins, which are important messaging molecules. We talked about this a little bit with fever. Remember prostaglandin E? Prostaglandins do a lot of things, inflammation, pain. We'll talk about those later. And the broader class of compounds, which are eicosanoids. We'll come back to those. They're very important messengers in the human body. So where do you get lipids? Most fatty acids are synthesized by the body. Essential fatty acids have to be consumed, linoleic and linolenic acid, but you then re-manufacture them into your own fats that you need. Saturated fats, mostly of animal origin, found in meat, eggs, dairy products, thought to increase the risk of cardiovascular disease. Unsaturated fats, found in nuts, seeds, most vegetable oils. Then cholesterol, generally found only in animal products. There is some plant cholesterol, but it's not a significant part of your diet. 80% of the body is made by your liver. So, you see if you watch TV, you think, oh, cholesterol, bad. Oh, yeah, no, you make 80% of your cholesterol. Whatever, 75%, doesn't matter exactly. But you make most of your cholesterol. You get some from your food. So why is it a big deal? Well, it's a big deal if you eat like the big Angus bacon cheeseburger and you get like 2 weeks worth of cholesterol in one burger. That's the problem. Cholesterol is good. The problem is too much. So notice in the upper right, cholesterol. See that 5 ring? That's going to be a giveaway. I'm going to come back to that. We're going to talk about that over and over again. That 5 ring structure. That's the way you recognize cholesterol, and that's the way you're going to recognize steroid hormones. Notice then in the lower right, saturated versus unsaturated. Saturated means every carbon is completely filled with hydrogens. Saturated means you've got a double bonded carbon. Why is that a big deal? Well, it's easier for your body to break it down and use it. You gonna eat that chair? This is irresponsible parenting. That's not this kid's fault. It's his parents' fault. Boneless bananas, 69%. 69 cents per cent. Okay, serum lipoproteins. So lipoproteins floating around in your blood. Lipids are transported as lipoproteins. Remember, this is what everybody's going to call cholesterol, and just smile inside and know that they're wrong. You don't have to tell them. They're actually proteins that transport cholesterol. Protein and phospholipid coat around a hydrophobic cholesterol and triglyceride core. They're soluble in plasma. That's the key here. By being proteins with hydrophilic heads, they are soluble in the plasma. So we got 4 groups. The more protein, the higher the density. Chylomicrons, those are the ones, remember, that we absorb into the lacteals in the small intestine. Then there's very low density, and high density. All right? So let's continue talking about this. Chylomicrons, they were absorbed into the lacteals, okay? We already talked about that. Form an absorptive cells of the small intestine, the epithelial cells in your small intestine. They enter the lymphatic system first, then eventually the blood in through the right lymphatic duct and thoracic duct and the subclavian veins. Monoglycerides hydrolyzed by lipoprotein lipase, all right? They're easy to work with. Monoglycerides, just one. Resulting free fatty acids and glycerol enter fat cells to be resynthesized into triglycerides for storage. And we talked about this before. The fats that you get, most dietary fats are triglycerides, but they're from animals and plants. They're not exactly the ones that you need. So you have to break them down into their component parts, then resynthesize them into your own triglycerides. Chylomicron remnant is degraded by the liver and then reused. So VLDL, LDL, HDL, VLDL, produced by the liver to transport lipids to adipose tissue for storage, all right? It plays a specific role in the human body. It becomes an LDL when the triglycerides are removed. LDL is what they call the bad cholesterol. The cholesterol has to be sent to the corner, cholesterol that didn't do its homework, didn't finish its meal. The reason they call it bad is because, well, first of all, it's absorbed by cells in need of cholesterol for membrane repair steroid synthesis. So it's carrying lipids to the cells of your body. They need that. The problem is they get stuck in the arteries and they form those atherosclerotic plaques. We looked at that when we covered the blood. Remember, we talked about that and I showed you a picture how ultimately they form the foam cells in the walls of arteries. That's the problem with LDL. HDL is the so-called good cholesterol. It did its homework. It goes to church, whatever. Liver produces an empty protein shell, and it travels through the blood picking up cholesterol. So basically, HDL rounds all the extra stuff up and then takes it back to the liver. Delivers cholesterol to the liver, and then it's eliminated in the bile. So it serves a function again. Total cholesterol, here are some numbers I actually want you to know. Remember, I always try to let you know when you do have to know numbers, when you don't have to know numbers. Here are some numbers that I do expect you to know. Total cholesterol should be less than 200 milligrams per deciliter. You know, ultimately these are arbitrary values, but they're determined by looking at health consequences and so on. You have to make a cutoff somewhere. It's somewhat arbitrary, but that's the typical cutoff. Below 200, not so bad. Above 200, that's a sign that you've got too much fat floating around in your blood. HDL should be between 40 and 60 milligrams per deciliter. LDL should be between 0 and 130. Triglycerides should be between 50 and 150. I'm sorry, you have to know those numbers. Just get used to them. Most cholesterol is endogenous, as I mentioned before, 80% roughly made by your liver. Dietary restrictions to lower blood cholesterol levels, well, you can lower them maybe 5% with restriction of dietary cholesterol. 15 to 20% with restriction of saturated fats. Vigorous exercise lowers blood cholesterol. So again, Just watch your diet. Remember, most of your cholesterol made by your liver. Just try to be reasonable with cholesterol in your diet and exercise. Those should help keep it under control. I can't believe it's not butterflies. Yeah, it's trying to watch its cholesterol as well. All right, select the correct statement. Here you go. Most cholesterol comes from your diet. LDL is the good cholesterol. Eating fiber can actually lower cholesterol. Glucagon lowers blood glucose. Lipoproteins cannot dissolve in blood plasma. So what do you say? Yeah, that's true. Most cholesterol comes from your liver, not your diet. LDL is the bad cholesterol. Glucagon raises blood glucose. Lipoproteins can dissolve. That's why they're so useful. There you go, as soon as it's over. You see on the right my little white tent? That's what I look at. That's my view every night before I go to sleep, and it's the first thing I see when I wake up in the morning. There's nobody else here but me. I've never seen anybody else at this place. It's a 50-mile four-wheel drive road to get here. Doesn't really show up on maps. GPS unreliable. You need a map and a compass. Good luck. If I ever see you here, I'll kill you. I'm just letting you know. Okay, I'll see you again in Metabolism PowerPoint number 4.